Good evening, my dear lovely JEE warrior lions. Welcome aboard to the Vedantu JEE English channel. And this is none other than your Captain Shreyas, your physics master teacher. And I hope you guys are doing great. And tomorrow is going to be Teachers' Day. And thank you for all the wishes and all the videos and all the things that you have been sharing and sending me on the social media as well. Thank you so much. And wish you all a very happy Teachers' Day too. And hopefully you will be blessed by all the teachers around you who is teaching you every single thing, and not just your physics, chemistry, maths, but so many teachers help you in so many different ways. So kudos to all of them, and I hope you receive all their blessings. Now today we are going to do all the PYQs from the work, power, energy chapter. Remember, just few days back we have done the work, power, energy theory, the concepts, the application. We have done all some problems, but now we also need to do some PYQs, and you need to start somewhere. You cannot say, sir, I want to start from 2010. You need to start somewhere. So why not start with the latest PYQs of both January as well as the April attempt JEE Mains PYQs, right, from 2024. So all the work, power, energy problems, there are not many, you will see. Okay, it's not a very high weightage chapter PYQ wise, but you will see the concept of work, power, energy is used in many places. Vanakam Dinesh, hello Harborine, Vijay Puligo, hello Nikhil, Sliari, just now completed the NEET live. Yes, I did a lot of lectures today. Yeah, hello Dark Knight. Oh, by the way, I already have a special surprise for all of you tomorrow, so stay tuned for it. You're going to love it. I received a box and I'm going to show you that box, what it is, and after watching that, I'm pretty sure you will be like, sir, where can I get that box? Okay, what is it in the box? You will get to know tomorrow or day after tomorrow. Okay, so in the next couple of days, you will see that small little gift from my side. All right, so let's begin with the class. First question coming up on your screen. Let's do the MCQs first. Here it is. There is a particle of mass m which is moving on a straight line with some speed. Along with some distance, the speed is changing given by this equation. The velocity is some constant root of x. Alpha is some constant. Okay. Total work done in moving it from this to this. Clearly there is a variation. So velocity is changing with x. So you might think that we might have to use some integration or derivatives. But I think we can avoid it if you know a particular theorem. See, usually our work is integration of force with respect to displacement, but I do not know the force, so I don't think I will be using this. Instead, how about finding the work by work kinetic energy theorem, which says work is delta K, that means it is final minus initial kinetic energy, which means it is half mass into V final square minus V initial square. Okay, so what is the V final value? It will be, substitute x as d, this is the final value. Substitute x as 0, that will be the x's initial value, which will give you initial velocity. So this is nothing but alpha root of x, x is nothing but d, so that is final velocity, minus initial velocity will be alpha root of, put x as 0, square it. Perfect. So this is just going to be half m, this is 0, alpha square into d. So therefore it will be m alpha square d whole thing divided by 2, which is option number C for Captain Shreyas. Hopefully you got it. Thank you, Gauri, for all the love from my home state, from my birth state of Tamil Nadu. Hello, Mekala Saravya. Hello, Unknown Spirit. Hello, Sumulata. Thank you for all the wishes. Yes, Arborine. The answer is C. Okay. Here comes the next interesting question from JEE Mains 2024 PYQs. There is a block which is simply, oh my god, such words, simply released, meaning just release, no speed from rest. It will slide down. This is a smooth surface. And once it comes down, there will be a spring, and this bottom surface is basically rough for the distance of 2 meters. and this spring has no roughness below it. Only for this much part there is roughness. So the spring will get compressed. So in this process, what happens is this block which is released from rest. Once it compresses it by an amount of x, it will again come to rest. So from rest to rest, maybe again we can use this work kinetic energy theorem. Hopefully it will help us again. So how about writing the work done by all the forces, like work done by gravity is there, work done by friction is there, work done by spring is there, work done by normal is there. All of them is final minus initial kinetic energy. Gravity only does work from here till here, only this much height, because here it is not moving up or down, so gravity won't do work. So how much is this particular height? Can you figure it out? If this is 10 meters, obviously this is 30, so this will be 10 sine 30. Sine 30 is basically half, so hence it is nothing but 5 meters. So gravity is going to act downwards, remember that. So gravitational force is going to act downwards. Motion is also downwards. So gravity does end up doing a positive work. So the work is positive. It is gravitational force. What is the gravitational force? Gravitational force will be mg. So it is 5g, which is basically 50 Newton. So I can say it is force multiplied by the displacement. Displacement is basically 5. Everybody clear till this point? Why the gravitational work is 50 Newton into 5? Force into displacement in the vertical direction. Great. Now, next, here friction is there. See what will happen. Friction will always oppose the motion. That frictional force will be mu into n. The value of mu is 0.5. The normal force obviously is going to be 50 Newton. So 5 5s are 25, decimal place cancels, so it will become 25 Newton. And friction will act opposite to the displacement. This 2 meters is the displacement. Hence, the work done by friction will be negative. Frictional force is 25, displacement is basically 2 meters. That's the work done by friction. Spring is getting compressed. Spring is absorbing the energy. So again, it is doing a negative work of half kx square, standard formula. Spring constant is 100. X is what? I do not know. Normal will not do any work. Why? Because every time the normal force is perpendicular to the displacement. So normal never ends up doing work in this particular case. Finally, it was at rest. Initially also it started from rest. So both the terms on the right hand side are 0. I hope this equation is absolutely clear. Okay. Sign is very important. Magnitudes are very important. Finding the forces are important. Checking the displacements very important. I was born in Salem, Saundarya. Thank you so much, Juju. Thank you. Yes, Srikant, I was born in Salem from Tamil Nadu. Alright. So 50 into 5 is 250 minus this is 50 right over here. And what else is there? I think in this particular problem, I'm not really sure whether the friction was here or was it here. See, if I assume the friction to be here, then this equation is correct. If I assume the friction to be in this part. But if for example, the friction is not here, rather it is in this particular part, which is over here, this much part, this friction is there. That friction, again mu n will come out to be 25 Newton. The only problem will be this displacement won't be 2 meters. It will be basically x. Which is the compression. So 25x. So minus 25x. It depends where that mu is. I think it is here because the arrow mark shows here, but not sure why they have put 2 meters. So the equation will change accordingly. If you solve it like this, then you will get a different answer. If you solve it like this, assuming the friction is here, you will get a completely different answer. Most likely the friction is not in this part. Most likely the friction should be here. But just showing you what happens if you assume it over here. This will become 250 minus 50. This will become minus 50x square is equal to 0. 250 minus 50 is basically 200 is equal to, take it on the other side, it will become 50x square. This will go 4 times. So x will be basically 2 meters. So x will be basically 2 meters. D is the option which is there, but I think yes, that is the correct answer right over here. Perfect. So x is equal to 2. So I think there was no clear clarity in this particular question as to where exactly the friction was, but I have assumed that the friction is here, then I get the answer. If I assume the friction to be here, I will get a completely different answer. So this will be 250 and this will be minus 25x. Instead of 50, you will get 25x. And here you will get 50x square is equal to 0. Divide everything by 25. Divide everything by 25. 10 minus basically x minus 2x square is equal to 0. So I will get 2x square plus x minus 10 is equal to 0. So from this, I will get two different roots. One will be positive, one will be negative. Ignore the negative, choose the positive. That is what you would do if the friction was assumed in this much part only, not in this much part. Understood how to solve the problem? Yep. Thank you, Shrikant. Thank you so much. Means a lot, bacha. Yeah. Sir, why is the work done by spring force negative? Okay. Straightforward. See, if you notice what is happening with the spring was earlier like this, then it became compressed. So on this particular block, the spring force on this particular block while it was compressing was like this, whereas it moved here, displacement was here. When force is opposite to the displacement, work done is negative. That's why I have taken negative work. Or think like this, friction is sucking away, spring is sucking away the energy. When you suck the energy, what happens? Obviously, negative work. When you do a good deed, when you give something, positive work. Got it? Cool? What if the friction is over the entire horizontal surface? Then this value of x will be 2 plus x. That's the only difference. If it was the entire surface, then it would be 2 plus x. I hope this is clear. Very good question, Nikhil. I hope all your doubts are now answered. So, as per the question, we will change the equation, but I think the diagram was not printed properly, not in the actual exam, but maybe over here. So, that's the reason why we have got a different, we have taken different cases. When kinetic energy of the body becomes 36 times of the original value, the percentage increase in the momentum would be. I think momentum and kinetic energy are related, and in our original work power energy session in our roar series, we have done a similar question, but the percentages were different. So kinetic energy formula is momentum square by 2m. So our final kinetic energy will be final momentum square by 2m, but this is 36 times of the original kinetic energy, and the original kinetic energy was p square by 2m. So this is p1 square by 2m. 2m cancels. So p1 square is basically 36p square. Taking roots, I will get p1 is 6 times of p, which means it is p plus 5p. Therefore, can I say that my new momentum is old momentum, this was your old momentum, plus 5 times. What is 5 times? 500% of p. 500% is 5 times. 100% of something is that complete thing, which is p. So 500 times 500% is 5 times. That's all. So that's why I think the increase in the momentum should be 500%, which is B for IIT Bombay. I know many people, after looking at 6p, they think answer should be 600%, and you would have got a negative mark. Okay, so be very careful. And then ideas, I will take magnetism after circular motion. Okay, after circular motion, we will do magnetism, because you will see in magnetism there are these problems where charged particles go in circular paths and all of that. I know it is not too much of an ask, but still, let's complete circular and then we will go to magnetism, matter, everything. Okay, but this month we'll be doing complete magnetism, EMI, everything. Let's complete it off. Electromagnetism should be done. Cool. So let's move on to the next one, guys. On your screen, there is a bullet which is fired. It enters a plywood, but it comes out with a lesser speed. Why? Because there is some loss of energy. Okay, so we have to find that loss. So let's find out the original kinetic energy. I mean, such questions are also asked as a very strange thing. Half into mass, which is 50 grams. So I will write 50 into 10 to the power minus 3 into velocity square, 100 square. Final kinetic energy will be half into mass, which is 50 grams, 50 into 10 to the power minus 3 into velocity. Final velocity is 40, so 40 square. So now, in order to find the percentage loss, all you need to do is take the initial, subtract it with the final, you will get the difference, divide it with the original. This will give me the fraction of the loss. So you multiply it by 100, you will get the percentage. The numerator represents the loss, the denominator says the original. So the fractional of loss into 100 gives me the fractional loss of energy. So when you subtract these and put this over here, one thing is there, these numbers are the same everywhere, if you notice. So in original, I can just put 100 square. In final, I can just put 40 square. In original, I can just put 100 square. There are few things which are just getting cancelled. Just getting cancelled. This thing over here. This thing over here. They will cancel. I hope you are able to see that. So this multiplied by 100. So that will be 100%. Here, 100 square, guys. So 4 zeros minus 1600 divided by 10,000, right? Multiplied by 100, 0, 0, 0, 0. This is all in percentages. I can still cancel these two zeros, these two zeros, these two zeros. 100 minus 16 is basically 84. So answer should be 84%. C for Captain Shreyas again. Very good, Harborain. Awesome. Very good, Nikhil. Yep, great. Yeah, I know, I can understand most of, South Indian languages like Kannada, Tamil, Telugu, but not, sometimes complex word comes means I will not know, or some difficult verb or noun will come means I will not know. That's the only problem. I can't talk very fluently, but yeah, I have an idea about most of it. Okay, 4 particles A, B, C, D of mass m by 2, m, 2m, 4m have the same momentum. The particle with maximum kinetic energy is same momentum, guys. Now, kinetic energy is momentum square by 2m. If momentum is same, kinetic energy is inversely proportional to the mass. So, the one which has maximum kinetic energy will have the least mass. Out of all of them, this is the one with the least mass. So, which is that particle? Particle number A. But particle A is option D. I mean, who is this paper setter, guys? Just look at it. Imagine in that moment, just picturize yourself. You are giving one of the most important exams in your life, which is going to decide your college, your branch, your future maybe. And in that exam, you have to mark this option, which is particle A, but that is option D. You'll be like, wait, option D is particle A, option A is particle D. You will be confused as hell at that moment. Maybe as a silly mistake, you will mark option A only. Who knows? Who knows? All right. Or you might think even more crazy level of silly mistakes can happen. Oh, it is A, so A is D, but D is C. So you'll mark C. Some random things can happen. That is why it is called silly mistakes. Okay. So be careful. Be calm in the examination. Let's do the next one. There is a body moving unidirectionally, means same direction. Under the influence of constant power, the displacement is proportional to this. Was one of the most repeated concepts even last year, even before this, guys. If you see, so many times this concept has been repeated. So let's have a look. First of all, power is constant power source. So power is a constant and power is force into velocity. Don't do anything with power. Remember, this particular power is a constant. What do I do? How do I find displacement? Okay, force, can I write it as something? Mass into acceleration, MAV. But acceleration is dV by dt. Perfect. So now I have an idea. Let's take dt on the other side. Let's put m also over here. So I can just write dt, and you can put p divided by m is equal to v dv. I just rearranged it. Why did I do that? Is because if I integrate both sides, I will get velocity and time relationship. So when I do the integration, I will get v square by 2, okay, and p by m is just a constant. Integration of time is just t. Limits are, if you are wondering, sir, what are the limits? Well, zero velocity initially, finally the velocity is v. So that's why this. Now just rearrange this further, I believe. So let's write down v square is equal to 2p divided by m into t. So v is basically root of 2p divided by m into t raised to half. Now write velocity as dx by dt. So velocity as dx by dt is equal to root of whatever this is into t raised to half. So dx will be root of 2p by m t raised to half into dt. Again the same logic, guys. Integrate here, limits 0, 0, x time. So let's see what do we get. So this will be just x, constant remains constant, t raised to 3 by 2 divided by 3 by 2. Clearly, x is directly proportional to the power of time raised to 3 by 2. Time raised to 3 by 2 is Bombay, IIT Bombay. Yes, Dark Knight. Yes, Bhavya. Very good. Hi, Raghavendra. Sir, by using work formula and integrate, you will get the answer. Yes. Sir, already you have taught this sum in some session. Yes, Bhava. I have done this. Like I said, this is one of the most repeated concepts. I would have done it, in fact, many times. Even 2023, 2022 paper discussions. Guys, we have been running this channel since 2020. The first paper I think we discussed was 2021, if I'm not wrong. And ever since, we have been discussing all the JEE mains papers, advanced papers, and even we have started with all the other examinations. So you would have seen this repeated many times. A body of mass 50 kg is lifted to a height of 20 meters from the ground in two different ways as shown. What is the ratio of the work done? In the first case, pulled straight up. In the second case, it is pulled along the incline. I mean, I want everyone to spam the answers in the chat box. Really. I mean, I really hate this question because it is too simple. Guys, as long as the height difference is same, the work done, which is a change in the gravitational potential energy, will be mgh. And can you not see whether it is here to here or whether it is like that? The height is the same, so delta u is the same, so work is the same, so it should be 1:1. Yep, very good, Jesus, Nikhil, awesome. C for Captain Shreyas, that's the answer. Very laddu question, and such laddu question came in the examination. Can you believe it? Okay, next question. A body of some mass slides from rest along this vertical circle starting from here and reaches over here on a smooth path. What is the speed at this point? Some values are also given. Okay, so let's analyze the motion. So there is something which is over here and it slowly follows this particular path, and by the time this mass reaches here, yep, so it has some velocity. Here it was at rest. So in this process, it has lost gravitational energy and it has gained kinetic energy. How much gravitational energy did it lose? Okay. For that I need to know the height. All right. How do I find out the height? No issues. Let's find it out. See, just drop a perpendicular like this. This is the complete height by which the mass has dropped. That will help us in calculating gravitational potential energy loss. How do I find that? Well, it is clearly mentioned the radius is basically 14 meters. Radius is 14. So, how much will this much be? Just tell me. How much will only this much be. 14 sine 45, 14 sine 45, and sine 45 is nothing but 1 by root 2. Okay. So, can you think and tell me what will be the total height? Right from here till here, it will be 14 plus 14 by root 2. Because remember, even this is 14 meters. This is also 14 meters. So, I can directly say that the gravitational potential energy gets converted into kinetic energy. Gravitational energy is mgh, kinetic energy is half mv square, mass gets cancelled. Gravitational acceleration is g, h is 14 plus 14 by root 2 is equal to half into velocity square. Solve this, you will get the answer. Solve this, you will get the answer in decimal places. I think it comes out 21.9 meters per second. So this value approximately comes out to 21.9 meters per second. It's very straightforward question, guys, nothing great. Okay. Intellectual booster cap 2, if I have 1% of your brain, array, my dear student, you have more than 1% of my brain, you have probably even 200% of my brain. I don't understand so many things these days. You are the next generation and already I feel so old, right? Because of the so many advancements are happening. You guys have been using technology at a much faster pace. You have been using it efficiently. So I'm pretty sure you guys will do wonders. So I'm pretty sure if you have that full confidence in you, you will not just crack any competitive exam, but also excel in that college, whichever you go. Okay, so have full faith. It's not about if, I'm telling you, you have it. Okay, so use that power which you have. If a rubber ball falls from a height h and rebounds up to h by 2, the percentage loss of the total kinetic energy, total energy of the system as well as the velocity of the ball before it strikes the ground respectively are. Okay, so again over here, simple logic. See, if there is a ball, it's at rest, it falls by a height of h and hits this particular ground over here. We all know this particular velocity of impact is nothing but root of 2gh. This is standard, you have learned that in one-dimensional motion, vertical motion. Root 2gh is only there in option A and D. So naturally option B and option C gets eliminated automatically. Next, it rebounds to a height of h by 2. So after rebound, okay, maybe the velocity becomes less and it reaches only till this particular height, which is h by 2. The question is the percentage loss of the energy. If you notice over here, the original potential energy gravity wise was mgh. Here gravitational potential energy is mgh by 2, which is basically half of the original. Original means this one, which means what? How much was lost? Half is left, so obviously half is lost. So half is lost. Half means 50%. So 50% is right over here. This gets eliminated, so it should be option A. Very, very straightforward, guys. Yeah. Thank you so much, Kirtika. Means a lot. And I just would be even more happy if my hard work pays off in, your live attendance, in your marks, in your improvement and your scores and colleges. That's all I want. So make sure you are spreading this joy of learning with all the kids around you, all the students around you. Let them know about the Vedantu JEE English channel, which is doing really awesome work, really hard work for all the students across the country. Okay, especially in a channel where in English, because there are plenty of mediums, plenty of channels doing really good work, of course, but only one channel, guys, and only one company. Just imagine, out of entire population of so many crores, just very few people thought that we should probably have a channel in English, which is mainly used in your day-to-day communication once you grow up in your PG colleges, in your work, in your PhDs, in your research, in your companies, or when you do business, when you go international. So I was very, very surprised. But anyways, moving on to the next one. A body of mass 2 kg begins to move under this force. The power developed at any instant is how much? Let's have a look. Oh, thank you V Enthuse Club for that amazing video. Guys, please check out V Enthuse Club. A very nice fanboy, a fangirl, I'm not sure. Made very, very nice videos. And V Enthuse Club is back after a long time, I think, after 2021, 2022. Thank you for all the awesome fan page videos, guys. Means a lot. Yeah. Yep. So looks like I have put on a lot of weight. I mean, if you look at that video, Shreyas sir, and this video, Shreyas sir, you'll be like, sir, what just happened? How many laddus did you eat? How many pizzas did you eat? How many gulab jamuns did you have? Well, maybe a lot, and you will see the difference. All right. So how do we do this question? I know the force. If I just knew the velocity, problem would have been solved, but unfortunately, I don't know the velocity. Thank you for all the Teachers' Day wishes, Cosmic, Karthik. Thank you so much. So what do we do? From force, let's find acceleration. Acceleration is force divided by mass. So 6t divided by mass, which is 2 I cap, plus 6t square divided by 2 j cap, which means the acceleration will be how much? 3t I cap plus 3t square j cap meters per second square. But acceleration is also derivative of velocity. I get a hint over here. If I shift it, integrate, I will get the velocity. So I can say the small change in the velocity will be 3t dt I cap plus 3t square dt j cap. And now is the time to bring back our snake from our basket. Yes, which is integration. So this is a snake, which is very helpful. 0, 0, 0 VPT. The moment you integrate, what do you get? You will get V is equal to, T's integration is T square by 2. So 3 by 2 T square I cap plus T square's integration is T cube by 3. So T cube by 3 J cap. But of course, over here, this 3 and this 3 just get vanished, it gets cancelled out. Now is the next part. Once I know the velocity and the force, I can find the power developed. And the power is force dot velocity. A lot of people are going to come in here. So 6t I cap plus 6t square j cap dot producted with this whole thing, which is 3 by 2 t square I cap plus this is just t cube j cap. Now, if you remember dot product, how it works, right? I cap will multiply only with I cap, j cap will only multiply with j cap, j dot I or I dot j is 0. So therefore, the power developed will be 6t into 3t square by 2, which is 6t into 3t square by 2 plus this into this, so 6t square into t cube. Okay, so this is going to be 2 and 6 cancels, 3 3s are 9, 9t cube plus 6t raised to 5. There you go. That is the answer, 9t cube plus 6t raised to 5. Obviously, it will be in watts because this is power. Is that right, everyone? Very good. Thank you, Madhav, for the wishes. Very good, Bhavya. Very good, Dark Knight, Lokesh, Sharburine. Yep, answer is D. A little lengthy, but yeah, doable. I mean, I won't say it is difficult, but yeah, the only catch was this part, to figure out velocity from force by integration on a 2D problem. It was not a 1D, it was a 2D. So you did integration operation on both I cap and j cap. Once you get the velocity, the second catch was here at the dot product part. You need to be very careful here. You can't afford any stupid mistake. Okay, let's see. There is some block. It's being pulled up, I think. And the question is, what is the work done against the frictional force? I don't know why they asked such a laddu question again. So over here, mg's cos theta will act here. What is the mass? 1 kg. So 1 g cos 60 This will be 1g sine 60. Force is acting like this. Friction will act like this, kinetic friction. And the value of the kinetic friction will be mu n. Mu is 0.1. Normal is like this. Normal force will be balancing 1g cos 60. So 0.1 multiplied by g is 10, cos 60 is half. 0.1 into 10 is 1, half is basically 0.5. So 0.5 Newton. But the question is to find the work done. So the work done by the friction will be negative because it is opposite to the displacement. So force of the friction multiplied by the displacement. So the force of the friction is 0.5, displacement 10 meters. 10 meters is the displacement along the incline. So it is basically minus 5 joules. But if you talk about the magnitude of the work, it is 5 joules. So I'll just mark it as 5. I know minus 5 would be more appropriate, but it's okay. You will not get bonus for that. Yeah, you will not get bonus. So don't expect that bonus. Okay, cool. Shall we go ahead to the next one? Very simple, guys. They just asked you work done by friction. So this 10 Newton was useless. Okay, unnecessary information just given to you over there. Let's solve the next question. There is a track, there is a ball, particle, and it is on a smooth track. It is gently pushed. So once it reaches point B, what is the speed? I mean, really, here it is having roughly 0 meters per second. By the time it reaches here, it has some speed. So in this particular process, obviously it has lost some height. And how much height has it lost? 1 minus 0.5, which is 0.5 meters. 0.5 meters. So gravitational energy went into kinetic energy. So mgh is equal to half mv square. Mm cancels. What is g? G is 10. What is height? It is 0.5. Half into v square. This is just 5 is equal to half v square. Therefore, v square is 10. Therefore, v is root of 10 meters per second. Yep, there you go. Root 10, where is it? Root 10 is C, Captain Shreyas again. Very good. Yep. Not D, not C. Darknet, what do you mean by not C, not D? Logic gates is going on. Sanjay, hello Kapil. Oh, I think you are in some other's account. Hi Karthik, thank you so much. Thank you so much for the wishes, Karthik. All right. Moving to the next question on your screen. Here it is. There is a body which is suspended light string like this. There is the body. It is given some velocity so that it is able to complete the circular track and it is able to reach the topmost point also. Find the ratio of kinetic energy at point A versus point B. This is a vertical circular motion problem. Although we have not done circular motion now, if you have studied before, and since we are just discussing previous year questions, means you would definitely know all the other concepts of other chapters. So at this point, for it to complete circular motion, the velocity should be root of phi gl. And at the topmost point, the velocity should be just root of gl so that the tension just becomes 0 and it is not slack. It is not slack at any moment. Nowhere does it become loose. It should be always tight. Only then it will complete the circle, or else it will become loose and fall off somewhere. So in order to find the ratio of kinetic energy at A upon kinetic energy at B, it will be just half m velocity at A square upon half m velocity at B square. What is velocity at A? Root 5 gl. So root 5 gl square. Here it is root gl at that point B square. Root goes, LL goes, GG goes, root 5 square is 5, root 1 square is 1. So 5:1 should be the answer. Just check it out. Yes, A is the correct answer. Okay. I hope this is clear, everyone. Shall we move ahead to the next question? Very simple. Next one, some block slides 10 meters. Friction coefficient is given, work done against friction. I mean, really, let's find it out. What is the work done against friction, guys? I don't know why they are obsessed with such simple questions. It's okay, good for us. So Gravitational force 100 G. Normal acts like this. Friction prevents sliding. So frictional force is mu n. Mu value is 0.4. Normal is 100 G. So G is basically 10. G is basically 10. 10 into 0.4 is 4. 4 into 100 is 400 Newton. At the same time, this block moves how many meters? 10 meters. So the work done by the friction will be negative. Force is 400. Displacement is 10. So minus 4000 joules. But we just give the mod value, which is 4000. 4000 joules. Yes, that's the answer. Option D. Cool. Shall we go to the next question, guys? Coming up on your screen. Get ready for it. Here it comes. Potential energy in a region is a function of x, y, and z coordinates, 3 coordinates. What is the x component of the force on the particle at this position? Which means forget everything else. Just focus your attention only on the x coordinate. That's it. Because they are asking you only for the x component of the force. The y and the z won't even matter. It is unnecessary. Chumma given to confuse you. We all know how this works. Force is negative gradient of the potential. I gave you this formula in the previous lecture. So just have to differentiate energy in that x direction, which is 2x square. Forget any other coordinate. So it will be negative 2. X square's derivative is 2x. So it will be minus 4x. But the question is, find that force at x equals to 1. Remember, x is 1. So it will be basically minus 4 into 1. So it is minus 4 Newton. So minus 4 Newton, or magnitude wise 4 Newton. Because they have asked you magnitude. So the magnitude of that force will be 4 Newton. 4 Newton, right? They have just asked the value of it. Simple. If it was y component, then you will only worry about 3y cube and you will substitute the y coordinate as 2. If it was z component, you will only worry about 2z and substitute the value of z as 3 in the end, not at the beginning, at the end. Cool? Yes. Okay, cool. Let's move to the next question on your screen. Here it comes. Bullet is fired, loses 1/3 of the velocity after moving some distance. It penetrates how much more before it comes to a halt? Before it comes to a halt. Let's understand what is exactly happening. It loses 1/3 of its velocity after traveling 4 centimeter. So this is basically 4 centimeter and it has traveled this much distance and loses 1/3 of its velocity. That means if the original velocity was v, it has lost 1/3. How much will be remaining? If it has lost 1/3 of its velocity, how much will be remaining? 2v/3 will be remaining. After this, it goes even further. I don't know how much distance it is, d centimeters. Okay, so or let's say we can just call it as x centimeters before coming to a complete halt. Before coming to a complete halt. As simple as that. Now in this process, what happens? There is some resistive force. Let's say I call it as F. That resistive force continuously does work. Resistance force continuously does work. So I can say, using work kinetic energy theorem, the work is the change in the kinetic energy. So in this case, the work done by this force will be F into 4. Let's do the problem in CGS system. Okay, it will be easy. So force into displacement with a negative sign. Why negative? Because force and displacement are opposite to each other. Final energy will be half into mass, not given, not needed also I think. Final velocity is 2v/3 square minus half mass into v square. This is one equation which I get. So if you want, I can just simplify this. So it will become m/2 and take that minus sign. So 4 times of f will become v square minus 4v square by 9. Because if I take the minus sign here, this will become plus. So plus v square. This will become minus. So minus. 2 square is 4. 3 square is 9. So this will become basically m/2. 1 minus 4 by 9 is 5 by 9. So 5 by 9 times of v square, that is 4 times of f. So that unknown force comes out to be m by 4 2s are 8 and 5 v square by 9. And just keeping it as it is, it's okay. I think later on it will cancel somewhere. Now for the second part, same logic if I apply, work done is change in the kinetic energy. The work done will be F into the displacement, which I don't know. Change in the kinetic energy, final minus initial. Initial will be this thing, half into m into velocity, which is 2v by 3 whole square. That force I already know. It is m by 8, 5v square by 9 into x is equal to minus half m, and this is 4v square by 9. A lot of stuff is again getting cancelled, like this 9 and this 9 over here, this v square, this m and this m, this 2, and this will become 4, this negative and this negative. Lot of stuff just got cancelled. So I am just left with x by 4 is equal to 4. Yep. So x, right? Is that right? X is equal to 16. X is equal to 16. Just check this out. Something is wrong. It penetrates how much distance further? Did we make some blunder somewhere? Oh, yes. We have forgotten that 5 over here. We have forgotten that 5. So 16 by 5. 16 by 5 still won't be. Yeah, that's fine. This is in centimeters. This is in centimeters, guys. So this is 3.2 centimeters, no problem. Which is same as saying 3.2 into 10 to the power minus 2 meters, which is same as saying 32 into 10 to the power minus 3 meters. So the answer should be 32, Bombay. Yep, that is correct. That is correct. So that 5 was there, which we missed. We put it later on. Yep. Can we use kinematic equations also? Yes, you can use kinematic equations also. Kishore, right now the crash course for JEE will begin probably November or October end, or somewhere in the month of October, not before that. But at the same time, you also have another option of joining or trying for the Ekalavya batch, but that is if you are confident with the basic syllabus. If not, then I would say wait for the crash course to be started. Okay. Oh, we have come to the numerical part. Let's see the numerical part. The force is acting, displaces it. What is the work done? Oh, this is straightforward, guys. Work done. Work done is integration of force with respect to displacement directly. It's a 1D motion problem. So integration of basically 3x square plus 2x minus 5 dx. Limits will be from 2 to 4. That's all. So 3 integration of x square plus 2 integration of x minus 5 integration of just dx, 2 to 4, 2 to 4, 2 to 4. That's it. So this will become x cube by 3 from 2 to 4 plus 2 into this will become x square by 2 from 2 to 4 minus 5 x from 2 to 4. 3 cancels, so it will become 4 cube minus 2 cube plus 2 cancels, so it will become 4 square minus 2 square minus 5, put 4 and then put 2. That's all. Solve this, guys. 4 cube is 64 minus 2 cube is basically 8 plus 4 square is 16 minus 4 minus, what is there? 4 minus 2, 2, 2 5s are 10. What is the answer that you are getting? Come on, quickly. Yep. Come on, guys. What is the answer that you are getting? 64 minus 8, 56, and then 16 minus 4, 12. Okay. Come on, guys. 68 minus 10, 58. So answer should be, just check it out, 58 joules. Yes, the answer is 58 joules, which is correct. Not very difficult. So you can see the level of paper is very, very easy to moderate only. Very few questions were difficult. Correct. That was the last question. And if you want to solve more previous year questions, remember the PYQ books. I've put up the link of 2022 and 2023 in the description box below, which has more than, thousands of questions. and all the questions segregated topic wise, chapter wise, with the solutions for all the 3 subjects. It's available at a very affordable price. It's less than 1000. It's hardly some 700-800 rupees, and you can get it couriered at your place. And it is good because your screen time will also reduce, or else you're always on the screen, so you can have that hard copy books and solve it. At the same time, let me also remind you that as you are watching this video, remember the scholarship entrance test for all the Vedantu courses, be it CBSE, be it NEET, be it JEE, also the test series. Scholarship exam is there, and this is not just for taking up the courses, plus there are prizes to be won. Number 2. Number 3, you also get to know where you stand at a national level. You are going to give a big exam. You are competing in your institute or maybe at a local level. But in this scholarship entrance exam, lakhs of students give this exam. So you will know exactly where you stand in the real competition, because you will be competing with other institute students also. Also, there are a lot of goodies to be won and a lot of free material resources only for those students who give this entrance test. So make sure you're registering for it. Link is there again in the description box. Enter your number, submit it, you will get OTP, and you can either do it offline or online, completely up to you. We have a lot of Vedantu learning centers spread across India. Just Google it out, maybe you will find one near you. Okay, so do not forget to comment work, power, energy done. Next chapter is going to be circular motion. Okay, so be ready for it, and make sure you're liking the video, sharing the video, and subscribe to the Vedantu JEE English channel. Bye bye, take care, hasta la vista, enjoy your day.